Hello, and welcome to Notes on 3.5, proving lines to be parallel. Now, in 3.1 and 3.2, we focused on this situation where we know that if two lines are parallel, like these two lines, then all kinds of angle relationships exist. For example, corresponding angles are congruent, consecutive interior angles are supplementary, alternate exterior angles are congruent, and I think I already said this, but consecutive interior angles are supplementary. Um, Today, we are going to be finding the converse of this. Okay, so remember, if P then Q, the converse is if Q then P. So we're going to say if we have this angle relationship, then the lines are parallel. Here we go. The first one is the converse of the corresponding angles postulate. What that says is that if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. The converse of the alternate interior angles theorem says that if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. The converse of the exterior angles theorem says the same thing, only about exterior angles. Have you noticed a pattern here? We're proving that lines are parallel with these angle relationships. The converse of the consecutive interior angles theorem says that if two lines are cut by a transversal so that consecutive interior angles are supplementary this time, meaning that they add to 180, then the lines are parallel. And lastly, the converse of the consecutive exterior angles theorem says that if two lines are cut by a transversal so that the consecutive exterior angles are supplementary, then the lines are parallel. All right, so the next theorem that's on here is the perpendicular transversal theorem. And another way that some people call that, these are basically the same name for one concept, which is that if two lines are perpendicular to the same line, then those two lines are parallel. Okay, sort of like what's going on here. So if P is perpendicular to R and Q is perpendicular to R, then P and Q are parallel. So I'm going to write that one more time, but I'm going to use math pattern, right? So if P is perpendicular to oh, that should be R, you guys. If P is perpendicular to R and Q is perpendicular to R, then P is parallel to Q. All right, let's look at these guided practice problems. Given the following information, which lines, if any, could be parallel? Verify your conclusion with the appropriate theorem or postulate. Now, because we're proving lines to be parallel, all of my verifications start with the converse of the. Okay, so what our job is going to be here is to locate these angles and to figure out which lines they would prove to be parallel. Each angle has to be touching one of the lines that they are proving to be parallel. So for example, 7 is congruent to 2. Now notice S is the transversal here, so the two lines that they would be proving parallel would be R and Q, and this would be by the converse of the alternate exterior angles theorem. Okay, then let's look at 11 and 14. Okay, so 11's right here and 14's right here. So in this case, P is our transversal and Q and R would be the two lines that we would be proving to be parallel. So R and Q. And that would be, based on the relationship and where these are, the converse of the alternate interior angles theorem. Okay, Next, number 3, if 7 and 16, now we already did number 7, right? And 16 is over here. Oh, in this case, Q is the transversal, and so the two lines that they would be proving parallel are S and P. S and P are parallel, and the verification of that would be the converse of the, and you have to look at what kind of angle relationship they have. One is inside, one is outside. They're at the same position at each intersection. So the converse of the corresponding angles postulate. Okay, and lastly, if the measure of angle 2 plus the measure of angle 6 equals 180, then the lines are parallel. Now, you'll notice that 2 is up here exterior to these two parallel lines, and that 6 is also exterior to Q and R. But the transversal that they're on the same side of is S. So we could prove that the lines R and Q are parallel by the converse of the consecutive exterior angles theorem. Okay, y'all, have a great day. Have fun with those practice problems.